Good morning, everyone. Welcome to Week 9. We are now building directly on what we covered in Week 8, where you learned how to complete a HIRC. You practiced the three-step process: hazard identification, risk assessment, and risk control, and you filled in an actual HIRC form. Today, we go deeper. We are going to answer questions that the basic HIRC raises but does not fully resolve. Why do some organizations use a 5x5 matrix instead of 3x3? What does ALA-ARP mean, and why is it the international standard for deciding when risk is acceptable? How does a HIRAC form fit inside a bigger organizational system? And perhaps most importantly, how do you build a workplace where people actually care about safety, not just comply with it? Those questions take us through 5 major topics today: the 3 types of risk assessment methods, risk rating in depth, safety management systems, proactive versus reactive monitoring, and safety culture. Each of these topics is assessed in both Mini Project 1 and Assignment 2, so pay close attention throughout. Let us go through the 5 objectives for today. These are sequenced deliberately. Each builds on the one before it. Objective 1. Distinguish between qualitative, semi-quantitative, and quantitative risk assessment methods, and select the appropriate approach for a given context. Not all workplaces need the same level of rigor. Knowing which tool fits which situation is a professional competency. Objective 2. Apply an expanded 5x5 risk matrix and explain the ALA-RP principle. The 3x3 matrix from Week 9 is suitable for most SMEs and routine workplaces. The 5BY5 is used in high-hazard industries and larger organizations. ALA-RP is the legal and ethical standard that decides where the boundary between acceptable and unacceptable risk sits. Objective 3. Describe the structure of a safety management system and explain how HIRC fits within the SMS cycle. HIRAC is a tool. The SMS is the system that keeps the tool alive and effective over time. Understanding how they relate is essential for any engineering technologist who will work in a large organization. Objective 4. Differentiate between proactive and reactive monitoring indicators and explain why leading indicators are more effective. This is a fundamental safety management concept, measuring what has gone wrong versus predicting and preventing what has not yet happened. Objective 5. Describe the 5 levels of safety culture maturity and identify the engineering technologist's role in advancing safety culture. Ultimately, all the tools and systems in the world only work if the people using them genuinely believe safety matters. That is safety culture.
Our first major topic is understanding the spectrum of risk assessment methods. Most of you will use qualitative or semi-quantitative methods throughout your careers. But you need to know all 3, where each sits on the spectrum of rigor, what each requires, and critique. Our first major topic is understanding the spectrum of risk assessment methods. Most of you will use qualitative or semi-quantitative methods throughout your careers. But you need to know all 3, where each sits on the spectrum of rigor, what each requires, and critically, when each is appropriate. Critically, when each is appropriate. There are 3 distinct approaches to risk assessment, and they represent a spectrum from least data-intensive to most data-intensive. The first approach is qualitative risk assessment. Risk is described using words or categories: low, medium, high. It relies on expert judgment and direct observation rather than numerical data. This is the approach you used in the HIRAC 3x3 matrix in week 9. When you scored a hazard as likelihood 2, medium, and consequence 3, major, you were making a qualitative judgment supported by experience and observation. The advantages are significant. It is fast, low cost, requires no specialist statistical knowledge, and is suitable for the vast majority of Malaysian workplaces. DOSH's HIRAC methodology is fundamentally qualitative. The limitation is that it is inherently subjective. Two experienced assessors looking at the same hazard might rate it differently, and that inconsistency can be problematic in complex legal or regulatory contexts. The second approach is semi-quantitative risk assessment. Here, you assign numbers to your qualitative judgments: likelihood from 1 to 5, consequence from 1 to 5, multiply them together, and use the score to plot the hazard on a matrix. The numbers look precise, but they still represent categories, not real statistical probabilities. A likelihood score of 4 does not mean a 40% probability of occurrence. It means likely, based on expert judgment. The 5x5 matrix we will look at in the next slide is semi-quantitative. It is more discriminating than a 3x3, which means you can differentiate between hazards that would otherwise receive the same score. It is widely used in Malaysian manufacturing, oil and gas, and utility companies. The limitation is that the numbers can create false precision. A risk score of 12 looks very specific, but it is still based on a subjective likelihood rating of 4. The third approach is quantitative risk assessment, specifically quantitative risk assessment, or QRA. This uses statistical failure rate data, fault tree analysis, event tree analysis, and mathematical modeling to produce precise numerical risk estimates expressed as probabilities. For example, the annual fatality risk from a particular operation is 3 in 100,000 per worker year. This level of precision requires extensive historical failure data, specialist software, and trained analysts. It is required under Malaysian law for major hazard installations, facilities storing large quantities of flammable, toxic, or explosive substances. As electronics engineering technologists, you will most frequently use qualitative or semi-quantitative methods. You should know that QRA exists and understand why it is required for certain types of facilities, particularly relevant if you work in the oil and gas, petrochemical, or utility sector.
Here is the 5x5 risk matrix. Notice that it gives you 25 possible combinations instead of the 9 from the 3x3. This finer discrimination is the key advantage. On the horizontal axis, consequence runs from 1, negligible, to 5, catastrophic. On the vertical axis, likelihood runs from 1, rare, to 5, almost certain. When you multiply these, the scores range from 1 at the bottom left to 25 at the top right. The 5 risk zones replace the 3 from the 3BY3. A score of 1 to 4 is low, monitor, no immediate action required. A score of 5 to 9 is medium, action within 6 months. A score of 10 to 14 is high, action within 1 month. A score of 15 to 19 is very high, action within 1 week. A score of 20 to 25 is extreme. Stop work immediately. Notice the critical difference from the 3x3. You now have a very high zone at 15 to 19 requiring action within 1 week, which sits between the month and the stop work threshold. In a 3x3, scores of 6 and 9 are both high and both require action urgently, but there is clearly a meaningful difference in priority between them. The 5x5 captures that difference. For your mini project 1, if your group is assessing a complex, multi-hazard workplace or a facility with high consequence potential, you may choose to use a 5x5 matrix. Be consistent. If you use 5x5, use it for all hazards in your assessment and document your rating criteria clearly.
ALRP stands for As Low as Reasonably Practicable. It is the internationally recognized standard for deciding when risk is acceptable, and it is referenced in OSHA 1994 through its requirement that employers do what is reasonably practicable to ensure safety. The ALARP model divides risk into 3 zones, shown here as a triangle. At the top, the unacceptable zone. Risk at this level cannot be justified under any circumstances, regardless of cost or benefit. If a hazard falls in this zone, work must stop until the risk is reduced. There is no cost-benefit argument here. The risk is simply too high to tolerate. An extreme score of 20 to 25 on the 5x5 matrix typically falls in this zone. In the middle, the ALARP zone, also called the tolerable zone. Risk here is tolerable, but only if it is reduced as far as reasonably practicable. The phrase reasonably practicable has a specific legal meaning. You must implement further controls unless the cost of those controls, in time, money, or effort, is grossly disproportionate to the risk-benefit gained. You cannot simply say it's too expensive unless the cost is genuinely disproportionate to the remaining risk. This is where engineering judgment matters most. At the bottom, the broadly acceptable zone. Risk here is so low that it requires no further action. Most everyday workplace activities, office work, walking through a corridor, using a computer, fall here. The risk exists, but it is negligible and requires no specific control beyond normal good practice. ALAR is not just a concept, it is a legal defense. If DOSH investigates an accident and asks, "Did you do everything reasonably practicable to prevent this?" Your HIRAR form, your control implementation records, your monitoring data, and your review history are the evidence that you operated in the ALRP zone. If you cannot show that evidence, you are likely to be found in breach of OSHA. In Week 8, we scored consequence in terms of severity of injury, minor, moderate, or major. That is appropriate for most HIRAR assessments. But a comprehensive risk assessment recognizes that accidents have consequences beyond bodily harm, and all of those consequences matter for the organization's risk exposure. The first consequence category is health and safety, the one we focused on in Week 9. Minor means first aid only with no lost time. Moderate means medical treatment required with some temporary lost time. Major means hospitalization, permanent disability, or fatality.
The second category is environmental. A chemical spill that is fully contained on-site is minor. A spill that reaches a drainage system and causes measurable local environmental damage is moderate and must be reported to the Department of Environment under the Environmental Quality Act 1974. A large-scale release that causes widespread contamination of a river system or groundwater, that is major with potentially permanent long-term damage and enormous regulatory consequences. The third category is property and asset. Minor damage costing less than Rm 10,000. A machine guard is scratched. Significant damage from Rm 10,000 to Rm 500,000. A circuit board tester is destroyed in an electrical fault. Major damage above Rm 500,000. A production facility is destroyed in a fire. The fourth category is business and production. A short disruption of less than 1 day, minor. Production loss of 1 to 7 days, moderate. An extended shutdown of more than 1 week, major with customer contract implications, revenue loss, and potential penalties. Why does this matter to you as an engineer? Because when you present a hierarch finding to management, you need to make the business case for your recommended control. This chemical spill could injure a worker, is important. This chemical spill could also trigger a DOE enforcement action, generate Rm 500,000 remediation cost, and shut the facility for 2 weeks is the complete picture. That complete picture is far more compelling for securing investment in risk controls.
Week 8, we scored likelihood based on a simple judgment of how often a hazard is likely to cause harm. Today, we understand likelihood as a function of 4 contributing factors that assessors should explicitly consider. Factor 1, exposure frequency. How often is the worker in contact with the hazard? A worker who is exposed to a chemical for 8 hours every day has a very different cumulative risk than someone who is exposed to the same chemical for 30 minutes on one occasion per month. DOSH guidance is explicit that exposure frequency is the primary driver of likelihood scores. Daily full-shift exposure to a hazard that causes harm slowly, like noise, dust, or solvent vapor, will always attract a higher likelihood score than occasional exposure, even if the harm from each individual exposure is minor. Factor 2, number of people exposed. A hazard that affects one operator working in isolation has a different collective risk profile from a hazard that simultaneously exposes 50 workers on an open production floor. When scoring likelihood for population-level risk, the number of people exposed must factor into your assessment. This is particularly important for shared facilities, common areas, and emergency scenarios. Factor 3, existing controls effectiveness. Your likelihood score must reflect the situation as it actually exists, not as procedures say it should be. If a machine guard is present but workers routinely bypass it because it slows production, the guard is not providing the protection it appears to provide on paper. Score likelihood based on the real control effectiveness you observe during your workplace inspection. Factor 4, human factors. A newly trained worker has a statistically higher likelihood of making errors than an experienced worker doing the same task. Night shift workers show measurably higher error rates than day shift workers. Fatigue impairs decision-making, reaction time, and attention. Workers under high pressure or performing unfamiliar tasks are more error-prone. Your likelihood rating should reflect these realities. If you are assessing a task that is done primarily by new workers under time pressure at night, your likelihood score should be higher than if the same task is done by experienced workers on day shift with no time pressure. Here is the 5x5 matrix applied to a real industrial scenario. The setting is a painting operation at an electronics enclosure manufacturing facility. Workers are spray painting metal enclosures with solvent-based paint for 6 hours per day, 5 days per week. There is currently no dedicated spray booth and no forced ventilation. Hazard 1, solvent vapor inhalation. This is a chemical hazard entering via inhalation. Likelihood is 5, almost certain because the worker is doing this for 6 hours every day with no ventilation whatsoever. Every single shift they are exposed to potentially dangerous vapor concentrations. Consequences 4 major because solvent vapor inhalation at chronic high levels causes irreversible neurological damage, liver toxicity, and occupational asthma. Risk score 5 multiplied by 4 equals 20 extreme. Required actions: stop work. Install a spray booth with forced exhaust ventilation before spraying resumes. Hazard 2 solvent fire and explosion. The same flammable solvent vapor creates an explosion risk in the presence of any ignition source, a spark from electrical equipment, a static discharge, even a light switch. Likelihood is 4 likely given the daily unventilated vapor accumulation. Consequences 5 catastrophic because a solvent vapor explosion can destroy the facility and kill multiple workers. Risk score 4 by 5 equals 20 extreme. Again, stop work. Eliminate all ignition sources and install explosion-proof ventilation immediately. Hazard 3 skin absorption of solvent. Even with inhalation controls, skin contact with solvent remains a hazard during spraying. Likelihood is 4 likely given the physical contact during the process. Consequences 3 moderate because most common painting solvents cause dermatitis, skin cracking, and some degree of systemic absorption over time. Risk score 12 high. Action within 1 month. Chemical-resistant gloves, barrier creams, appropriate protective clothing. Hazards 4 and 5, noise from spray equipment and ergonomic strain from overhead spraying, score medium at 6 each. Action within 6 months. What does this example demonstrate? That a single, seemingly routine industrial operation can contain multiple extreme and high hazards, 2 of which require immediate work stoppage. Without a systematic risk assessment, a manager might see spray painting as just painting and provide basic respiratory PPE. The 5 by 5 assessment makes the true risk visible and inarguable.
We now move to our third major topic, safety management systems. This is where risk management stops being a series of individual tasks, a hierarchy here, an inspection there, and becomes an integrated organizational system. The question this section answers is, how does an organization make safety systematic, sustainable, and continuously improving? The answer is an SMS. A safety management system is the organized framework of policies, processes, and procedures that systematically manages safety across an entire organization, not just at the level of individual tasks or workstations. Let me be direct about why hierarchy alone is not sufficient. Imagine an organization that completes a hierarchy for every operation. Forms are signed, filed, and stored. Then, nothing happens. The recommended controls are never implemented. The form is never reviewed after a near miss. 6 months later, a new chemical is introduced and no one updates the hierarchy. 2 years later, a worker is injured by a hazard that was identified but never controlled. That is not a hierarchy failure. That is an SMS failure. The hierarchy was a correct tool, correctly applied. But without a system to implement the findings, monitor the controls, review the outcomes, and drive improvement, the tool is useless. Accidents rarely arise solely from a single physical hazard. They arise from combinations of management failures, a procedure that was written but not communicated, a control that was installed but not maintained, a near miss that was observed but not reported, a review that was scheduled but never conducted. An SMS addresses the organizational and management dimensions of safety, not just the physical hazard dimension. On the right side of this slide, you can see what an SMS provides. A safety policy commits leadership in writing and in practice to safety as a non-negotiable organizational value. Planning tools, including hierarchy, identify and address risks before they cause harm. Implementation systems define who does what, with what resources, and to what standard. Monitoring measures whether the system is working. And review cycles feed the results back into the next planning round. Without all 5 of these elements functioning together, You do not have an SMS. You have a collection of safety documents. The structure of an SMS follows the Plan-Do-Check-Act cycle, the same continuous improvement framework used in quality management. Let me walk you through all 4 quadrants. Plan. This is where the SMS starts. You set safety policy and objectives. You identify all legal compliance requirements. You conduct hierarch. This is where hazard identification and risk assessment live in the SMS. You establish emergency preparedness plans. Everything you learned in week 9 sits in this quadrant. Do. The plan is implemented. Risk controls identified in hierarch are physically installed, implemented, and enforced. Workers are trained on the controls and on their responsibilities. Safe work procedures, the SOPs, are written, distributed, and followed. Safety information is communicated to all workers, not just supervisors. Check. You verify that the plan is working. You monitor workplace conditions to confirm that controls are in place and effective. You investigate every accident and near miss, not to assign blame, but to understand system failures. You conduct internal safety audits. You measure performance using leading and lagging indicators, which we will cover in detail in the next section. ACT. You respond to what the check phase found. Management reviews the performance data. Gaps are identified and corrective actions are implemented. Hierarch forms are updated to reflect any changes in processes, equipment, or exposure patterns. New objectives are set for the next PDCA cycle. The gold circle in the center of this slide is labeled PDCA cycle because this is not a linear process. It is continuous. The act phase feeds back into the plan phase. There is no endpoint. In a well-managed SMS, the cycle runs indefinitely, with each revolution producing a safer, more efficient, more legally compliant organization. MS 1722:2011 is the Malaysian standard for occupational safety and health management systems. ISO 45001 is the international equivalent. Both are structured around this PDCA cycle. This slide makes explicit something that is easy to miss. Hierarch is not separate from the SMS. It is the core risk management mechanism within the plan phase. But its outputs flow through every subsequent phase. In the plan phase, hierarch is conducted. Hazards are identified, risks are scored, controls are selected, forms are signed and filed. This is where the system decides what needs to be done. In the DO phase, the controls selected in hierarch are physically implemented. Workers are trained on those controls. SOPs are written that incorporate hierarch findings. A hierarch that recommends installing a fume hood is only as valuable as the fume hood that is actually installed, connected, and maintained. In the check phase, inspections verify that the controls recommended in hierarch are in place and working. If an incident occurs, investigators check whether the hierarch correctly identified the hazard, whether the recommended control was implemented, and whether it was maintained. A near miss triggers a hierarch review. In the ACT phase, hierarch forms are updated based on what check found. New equipment, new chemicals, new processes, changes to worker numbers, or shift patterns all trigger a hierarch update. Management signs off on the updated forms. The key insight at the bottom of this slide is worth reading carefully. A hierarch completed under plan without follow-through in do, check, and ACT is administrative compliance only, not real safety management. Many organizations complete hierarch because DOSH requires it, file the forms, and move on. That achieves legal minimum compliance, but does not make the workplace safer. Real safety management is the SMS functioning as a complete cycle with hierarch at its center. Our fourth major topic is monitoring, specifically the distinction between reactive and proactive monitoring. This is a conceptual shift that separates organizations that manage safety systematically from those that simply react to accidents. The central question: would you rather know that an accident has happened or know that an accident is about to happen? The answer seems obvious. But most organizations measure the wrong things and only find out their safety system has failed when someone is already hurt. There are two fundamentally different types of safety performance measurement. Understanding the difference is one of the most practically useful things you will take from this course. Lagging indicators are reactive. They measure outcomes after harm has already occurred. The four most common lagging indicators in Malaysian workplaces are the Lost Time Injury Frequency Rate, LTIFR, which is the number of lost time injuries per million hours worked. This is the indicator most frequently reported to DOSH and to management committees. The problem with LTIFR is obvious once you think about it. It only changes when someone has been seriously enough hurt to miss work. By the time your LTIFR rises, the accident has already happened and a worker has already been injured. The Total Recordable Incident Rate, TRIR, captures all recordable injuries, not just lost time cases. It is a broader indicator, but it is still reactive, still measuring failure. The fatality rate is the ultimate lagging indicator. 0 deaths tells you nothing about whether your safety system is working. It may simply mean you have been fortunate. A fatality tells you your system has catastrophically failed, but it tells you after the fact. DOSH enforcement actions are also lagging. They occur after a violation has been found, which typically happens after an incident. Leading indicators are proactive. They measure the health of your safety system before incidents occur. Think of them as early warning signals that tell you whether your system is functioning as it should. Hierarch completion rate. What percentage of your operations currently have assigned up-to-date hierarch? If the answer is 60%, 40% of your operations have unmanaged, undocumented risks. This is a leading indicator because it tells you about risk before accidents happen. Near-miss reporting rate. How many near misses are your workers reporting per month? A high and rising near-miss reporting rate is a sign of a healthy safety culture where workers trust the system enough to report incidents that almost happened. A low near-miss rate does not mean a safe workplace. It often means workers are not reporting. Organizations with strong safety cultures typically report 50 to 100 near misses for every recordable injury. Safety training compliance. What percentage of workers have current, valid competency certification? Gaps in training predict accidents. A worker who has not been trained on the hazards they face every day is at elevated risk. Safety inspection frequency. Are your scheduled safety inspections actually happening on time? An inspection rate that falls below 90% means hazards are going unidentified for weeks or months. This slide shows 6 specific key performance indicators that engineering technologists in safety-critical roles are expected to monitor and report. Let us go through each one. LTIFR, Lost Time Injury Frequency Rate. Formula: lost time injuries multiplied by 1 million, divided by hours worked. The target for Malaysian manufacturing is less than 2.0. This is the primary lagging indicator, and the one most likely to appear in your organization's monthly management report. Near-miss rate. Formula: near misses reported divided by total workers, multiplied by 100. Target: a rising rate indicates improving culture. This is counterintuitive. More near-miss reports is better, not worse. It means your workers trust the reporting system and management's response. Hierarch coverage. Formula: operations with a current hierarch divided by total operations, multiplied by 100%. Target: 100% at all times. Any gap represents unmanaged, undocumented risk. As the safety responsible person, you are accountable for this number. Training compliance. Formula: workers with valid certification divided by total workers, multiplied by 100%. Target: 95% or above at all times. Gaps trigger refresher training, not optional, not deferred. Inspection completion rate. Formula: inspections completed divided by inspections scheduled, multiplied by 100%. Target: 95% or above on time. If inspections are being deferred consistently, It indicates that safety is being deprioritized in favor of production, a leading indicator of future incidents. Corrective action closure rate. Formula: closed actions divided by total open actions, multiplied by 100%. Target: 90% closure within agreed time frames. An accumulation of open overdue corrective actions is a direct indicator that your risk controls are not being implemented and that your hierarch outputs are not being acted on. These 6 KPIs together give a complete picture of SMS health. An organization with a high TIFR but good leading indicators is improving. An organization with a low TIFR but deteriorating leading indicators is heading toward a major event.
Our final major topic is perhaps the most important of all and the hardest to measure. Safety culture is the collection of shared values, beliefs, and behaviors that determine how safety is actually managed in an organization, including when no one is watching. You can have the most comprehensive hierarch, the most sophisticated SMS, the most detailed SOPs, and the most rigorous monitoring system. None of it functions if the people who work in the organization do not genuinely believe that safety matters. Culture is the invisible force that determines whether safety systems are used as intended or bypassed in the pursuit of productivity. Heinrich's triangle, also known as the accident pyramid, is one of the most influential models in occupational safety. Originally developed by Herbert Heinrich in the 1930s and refined through subsequent research, it describes the relationship between different levels of safety events. At the very top of the pyramid, one fatality or major injury. Below that, for every fatality, there are approximately 10 minor injuries, cuts, burns, bruises, sprains. Below those, for every 10 minor injuries, there are approximately 30 property damage incidents, near hits where something was damaged but nobody was hurt. And at the base, for every 30 property damage incidents, there are approximately 600 near misses and unsafe acts, situations where the potential for harm existed. Something went slightly wrong, but by chance, no injury and no damage resulted. The practical implication is profound. You cannot prevent fatalities by focusing on fatalities. By the time they occur, the opportunity for prevention has long passed. But you can prevent fatalities by systematically addressing what is happening at the base of the pyramid, the near misses and unsafe acts. Every near miss is a system telling you the conditions for a serious accident are present. Act now before the random factor that saved you this time is absent. This is why near-miss reporting is a leading indicator. An organization with a high near-miss reporting rate is not more dangerous than one with low reporting. It is more honest about the hazards that exist, and therefore in a much stronger position to address them before they escalate. The annotation on the right side of the pyramid says, intervene here to prevent this. Intervene at the base, address near misses and unsafe acts, and you prevent the minor injuries above. Address minor injuries systematically, and you prevent serious injuries. Address serious injuries and fatalities become statistically improbable. The goal is not zero accidents. The goal is a system where accidents are systematically driven towards zero by addressing the conditions that produce them. Hudson's Safety Culture Maturity Model describes 5 levels of organizational safety culture, ranging from the lowest, pathological, to the highest, generative. This model is used by DOSH, the oil and gas industry, aviation, and major multinational manufacturers to assess where their organization currently sits and to set targets for improvement. Level 1, pathological. The defining belief at this level is, who cares as long as we do not get caught? Safety is only addressed reactively after accidents occur, and even then, the primary motivation is avoiding regulatory consequences rather than genuinely protecting workers. The dominant management style is blame. When accidents happen, the focus is on finding who was at fault, not on understanding the system failures that produced the accident. Workers hide incidents because they fear punishment. Near-miss reporting rate is effectively 0. Level 2, reactive. The belief here is, safety is important, we do something after accidents. There is genuine concern for safety after incidents, but the response is still reactive. Safety meetings are called after accidents. HIRARC is completed when DOSH requires it, but is never reviewed or updated. There's more awareness than at level 1. But the system is still fundamentally driven by events rather than anticipation. Level 3, calculative. The belief is we have systems in place to manage all hazards. This is where many well-intentioned organizations plateau. They have HIRARC, they have an SMS, they have training records, they conduct audits. But the system is driven by management. Workers are passive recipients of safety programs rather than active participants. Safety is something that management does to workers, not something workers own. Compliance is reasonable, but the culture is technocratic rather than values-based. Level 4, proactive. The belief is we try to anticipate problems before they occur. Workers actively report near misses without prompting. Safety improvement is genuinely part of everyone's job, not just the safety officers. Management and workers collaborate on identifying hazards and improving controls. Near-miss reporting rates are high and rising. The focus has shifted from compliance to prevention. Level 5, generative. The belief is safety is how we do business here. Safety is embedded in every organizational decision, investment decisions, hiring decisions, production scheduling decisions. The organization has a high near-miss reporting rate, continuous learning from every incident, and zero tolerance for known risks. Workers and management share a common understanding that safety and productivity are complementary, not competing. The note at the bottom of this slide is important. Most Malaysian SMEs operate at level 2 to 3. Best-in-class multinationals, DuPont, Shell, Siemens, operate at level 4 to 5. The target for an organization implementing a new SMS is to reach level 4 within 3 years of implementation. That requires consistent, visible leadership commitment, a functional near-miss reporting system, and genuine worker involvement in safety management.
We have 5 minutes for a quick individual check before we close. Look at the 4 questions on the slide and write your answers. Then turn to the person next to you and compare. You have 2 minutes to discuss any differences. Question 1. A risk score of 12 on a 5 by 5 matrix. What is the risk level and what is the required response time frame? Answer. A score of 12 falls in the high zone, scores of 10 to 14. Required action within 1 month. This is a meaningful step up from a score of 9, which would be medium, with a 6-month time frame. The 5 by 5 captures this difference, the 3 by 3 does not. Question 2. Your organization's LTIFR has been 0 for 12 months. The safety manager calls it a success. Why might a rising near-miss reporting rate actually be a better sign of safety culture improvement? Answer. An LTIFR of 0 tells you no one has been seriously hurt yet. It does not tell you whether near misses are occurring and being ignored, whether hazards are being controlled, whether training is current, or whether HIRARC is up to date. A rising near-miss reporting rate indicates that workers trust the system enough to report problems, which means the organization is identifying and addressing precursor conditions before they escalate. LTIFR is a lagging indicator. It measures past failures. Near-miss rate is a leading indicator. It predicts future performance. Question 3. Which phase of the PDCA SMS cycle involves conducting HIRARC, and what happens to HIRARC outputs in the DO phase? Answer. HIRARC is conducted in the plan phase. It is the primary planning tool for identifying and assessing risks. In the DO phase, the risk controls selected through HIRARC are physically implemented, workers are trained on those controls, and SOPs are updated to reflect HIRARC findings. Question 4. An engineering technologist notices a worker consistently bypassing a machine guard because it slows them down. The technician does not report it. Which SMS failure does this represent, and at which safety culture maturity level does this behavior occur? Answer. This represents a check failure in the SMS. The monitoring function has identified a non-compliance, but the corrective response has not occurred. It also represents an ACT failure because the finding is not feeding back into corrective action. In terms of culture maturity, tolerating and not reporting unsafe behavior is characteristic of level 2, reactive, or worse, level 1, pathological.
A Level 4 organization would not have a worker who bypasses guards without it being immediately reported and addressed. In this slide, we are going to look at a very practical, real-world OSH program developed by DOSH, the Department of Occupational Safety and Health Malaysia, specifically for small and medium enterprises or SMEs. The program is called Solve for SME, which stands for Stepwise OSH Level Verification and Enhancement for Small and Medium Enterprise. It was published in 2021 and runs from 2021 to 2025. Why is this relevant to us in NMK 44403? Because everything we have been learning, HIRARC, OSHA 1994, the hierarchy of controls, safety culture, this program puts all of that into practice in Malaysian workplaces. Let's see how. First, let's understand why this program was created. Look at these numbers. As of December 2020, SMEs, Perusahaan Kecil dan Sederhana, made up 97.2% of all business establishments in Malaysia. That is 1.15 million businesses. So when we talk about OSH in Malaysia, SMEs are the majority. Now, DOSH had been running compliance support programs for SMEs since 2008. And after all those years of work, they identified two main root causes of why SMEs keep failing to comply with OSH laws. First, lack of funding. Many SMEs simply cannot afford to hire dedicated OSH personnel, buy proper equipment, or set up systems. Their margins are tight. Second, no dedicated OSH person. In a small factory or workshop, everyone is doing multiple jobs. Nobody is specifically assigned to handle safety. So safety gets neglected, not out of bad intention, but out of limited resources. Solve for SME was designed specifically to address these two problems. The key design principles were high impact, low cost, easy to implement, and applicable to all SME sectors. It had to be something a small workshop in Perlis could actually do. So what exactly is the program? The targets are ambitious but realistic. Reach 1,000 SMEs over 5 years, engage 10,000 employers and workers, and aim for 75% of participating workplaces to reach level 3 or above. Now, the program has two parallel elements that every SME must work on simultaneously. Element 1 is OSH management. This covers the management side. Do you have safety policy? Do you have a safety committee? Have you done risk assessments? Is someone responsible for OSH? Element 2 is workplace improvement. This covers the physical conditions. Is your workplace clean and organized? Do you have fire extinguishers? Do you have PPE? Are your chemicals properly stored and labeled? And here is the key rule that I want you to remember. The overall level of a workplace is determined by the lower of the two element scores. So if a company scores level 4 in OSH management, but only level 2 in workplace improvement, their overall level is level 2. You cannot have good paperwork and a dangerous workplace. Both must improve together.
Level 3, Silver. Level 3. Now, let's walk through the 5 levels. Think of it as a ladder. Each rung adds more requirements. Level 1, Basic. This is the entry point. The employer must show commitment to the program, appoint a person in charge, called PIC, and attend the introductory briefing. On the workplace side, the company must be registered with JKKP. That's it. The bar is intentionally low because the goal is to get SMEs started. Level 2, Bronze. Now we get serious. The PIC must attend a one-day training on OSH law and management basics. They must prepare an action plan, a Gantt chart. They must run internal training for their workers. On the policy side, a written safety and health policy must be produced. If there are 40 or more workers, a safety and health committee must be established. On the physical side, 3S housekeeping, clear walkways, fire extinguishers, first aid kit, and an OSHWA physical audit grade of C. Level 3, Silver. This is where risk assessment comes in, and this connects directly to what we teach in this course. The PIC must attend training on risk assessment. The company must actually conduct HIRARC, hazard identification, risk assessment, and risk control, and document it for all work activities. JKK meetings must be held.
An accident reporting procedure must be in place. On the physical side, PPE, chemical storage, warning signs, emergency plan displayed, an assembly point, an OSH notice board, and OSHWA Grade B. Level 4 Gold. Now we move to OSH management systems. The PIC attends 2 days of OSHMS training. The company conducts CHRA, Chemical Health Risk Assessment, and NRA, Noise Risk Assessment, if relevant. An emergency response team is established. The company must have 0 HUK accidents in the current year. 50% of the recommended control measures from the risk assessment must be implemented. Physically, chemical register. SDS at chemical storage areas, safe electrical installations, basic welfare facilities, certified machinery with registration numbers displayed, emergency contact numbers posted, emergency drills conducted, and OSHWA Grade A. Level 5, Platinum. The highest level. The company must have an ISO 45001:2018 certification or a practiced OSHMS. 0 fatalities at the workplace in the current year. All recommended control measures must be implemented. Safe work procedures must exist for all plant and machinery activities. And the OSHWA SBKKP audit must achieve Grade A. Notice how the levels align perfectly with the Plan Do Check Act cycle that we discuss when we cover OSHMS.
How does DOSH actually verify that a workplace has reached a particular level? They use 3 checklists found in the appendices of the guideline. Appendix 8.1, OSH Management Checkpoints. These are the management side criteria organized by level. Each checkpoint has a yes-no answer and a guidance column showing what evidence is required. For example, checkpoint A11 has risk assessment been conducted, requires the actual hierarchic documents for all work activities as evidence. Appendix 8.2, Workplace Improvement Checkpoints. These are the physical side criteria. Checkpoints like, are there adequate PPE provided? Is there a chemical storage area? Are there warning signs displayed? Evidence is the OSHWA physical audit report generated through the MyKKP online system. Appendix 8.3, OSHWA Checklist. OSHWA stands for Occupational Safety and Health Workplace Assessment. This is a comprehensive audit tool covering 3 parts: a documentation audit, a physical audit, and a 5P SBKKP audit, which assesses the full OSH management system cycle: preparation, planning, implementation, monitoring, and improvement. The OSHWA generates a grade from A to E. Workplaces need Grade C for Level 2, Grade B for Level 3, and Grade A for Level 4 and above. Remember, the JKKP officer reviews and verifies everything the PIC has self-assessed. The PIC does the groundwork. The officer validates it. For a company to move up the ladder, their PIC must complete structured training at each level. Level 1, half a day employer and PIC together, introduction to the program. Level 2, 1 day for the PIC, covering OSH law basics and OSHWA self-assessment. Level 3, 1 day on risk assessment, including practical hierarchic document preparation. Level 4, 2 days on OSHMS. Level 5 has no additional formal training, but the company must demonstrate full OSHMS implementation. This is important. Training is not just a box to tick. The PIC must then bring this knowledge back and train their own workers internally. So the knowledge spreads into the company. On recognition, all participating workplaces receive a participation certificate. Those who reach Level 5 Platinum receive a recognition certificate and become eligible for nomination to the National OSH Excellence Award in the SME category, and even international awards. 4 OSH practitioners, safety and health officers, OSH coordinators who voluntarily help SMEs implement the program. They earn continuing education points. These points are required to renew their competency certificates with JKKP. So it benefits the practitioners too. At Level 3, they earn 10 CEP. Level 4 gives 16 CEP, and Level 5 gives 20 CEP. Now, let me make the direct connections to our course outcomes. HERARC at Level 3, conducting HERARC is a mandatory checkpoint. Checkpoint A11 requires documented risk assessments for all work activities. This is exactly the tool we study in CO4. OSHA 1994, Sol 4 SME, is built on this act. The safety policy required at Level 2 references Section 16. The Safety and Health Committee at Level 2 references Section 30. The requirement for a safety and health officer in certain industries is assessed in the OSHWA documentation audit. Hierarchy of controls. At Level 4, 50% of the recommended control measure from the risk assessment must be implemented. At Level 5, it must be 100%. This directly tests whether companies are applying the hierarchy of controls, elimination, substitution, engineering controls, administrative controls, PP. Safety culture. The entire stepwise progression is a model for building safety culture. Level 1 is commitment from the top. Level 2 is policy and committee formation. Level 3 is active risk assessment. Level 4 is systematic management. Level 5 is full OSHMS. This is safety culture growing from awareness to excellence. Let's wrap up with 6 key points to remember. 1. Sol 4 SME is Malaysia's official, structured OSH compliance support program for SMEs, targeting 1,000 workplaces over 2021 to 2025. 2. It assesses 2 parallel elements, OSH management and workplace improvement, across 5 progressive levels from basic to platinum. 3. The overall level is always the lower of the 2 element scores. You cannot compensate a bad physical workplace with good paperwork. For everything we study in CO4, HERARC, OSHA 1994, Hierarchy of Controls, OSHMS, is directly embedded in the program criteria. 5. Recognition ranges from a simple participation certificate all the way to eligibility for the National OSH Excellence Award. 6. OSH practitioners who help SMEs voluntarily earn CEP points toward renewing their competency certificates. I will leave you with the program's own quote. Safety does not come with luck. It has to be prepared. That really sums up everything we're trying to teach in this course.